Hello everyone, welcome back to another video. In today's video we will talk about the Matplotlib, a Python library widely used for creating visualizations and plots. Before we begin, make sure you have Google Colab up and running. You can also use other code editors if you want. I'm going to use Google Colab in the video. In the first step, we will import the necessary libraries. Matplotlib is often used in conjunction with NumPy, so let's import both of them. We are going to import NumPy as MP and import matplotlib.pyplot as plt here. With our libraries in place, let's proceed to generating a dataset that we'll use for our plotting examples. I'm going to use some NumPy methods for this operation. Firstly, let's start by creating our X. And now we are going to create our Y here. We now have our dataset ready. It consists of 100 data points, evenly spaced from 0 to 10 with some added noise. Now let's jump right into our first plot, a simple line plot. For this we are going to just use like plt.plot and we are going to pass x and y, and let's add a title. With that title we are going to say line plot, and let's give a name to the x-axis with plt.x label, and also do the same for the y. And at the final stage we are going to use plt.show. Seems nice. We have just created our first plot using Matplotlib. As you can see, we plotted the values from our dataset x against y, resulting in a line plot. We also added a title labeled the x and y axis and displayed the plot using plt.show. Now let's explore some other types of plots. The next one we will cover is a scatter plot. For creating a scatter plot, we are going to say plt.scatter, and we are going to pass x and y again, and we are going to add a title as scatter plot. And let's also do the operations for the x label and y label. And at the final stage, let's use plt.show. And there we have it. Scatter plots are great for visualizing the relationship between two variables. In this case, we have plotted the points from our dataset, resulting in a scatter plot. Notice how the points are not connected with lines, unlike the line plot. Next up, let's explore bar plots, which are useful for comparing categorical data. For this operation, we are going to start by creating categories. And let's say A, B, C, and add D and E here. And we are going to add some values here. 15, 7, 10. I'm just randomly writing 12, 8. And now we are going to use plt.bar for creating a bar plot. We are going to pass categories and values here. Let's add a title with plt.title once again as bar plot. And use x label for categories and y label for values. And we are going to use plt.show once again. And there we have it. Bar plots provide an effective way to visualize categorical data. In this example, we have categories A through E with corresponding values. The heights of the bars represent the values for each category. Now let's take a look at another popular plot type, histograms. Histograms are ideal for visualizing the distribution of a dataset. I'm going to use the Y that we created earlier in this video. We are going to use plt.hist. We are going to add Y and bins here. plt.title histogram. We are going to add X label as values and Y label as frequency. And at the final stage, we are going to use plt.show. Histograms provide insights into the distribution of data. In this case, we are visualizing the distribution of our dataset Y. By specifying the number of bins, we control the granularity of the histogram. Let's explore one more plot type, the pie chart. Pie charts are useful for displaying proportions and percentages. Let's move to the next cell. We are going to create labels quickly. We are going to say category A, category B, and category C in a list. We are going to add sizes here. 40, 30, and 30. We are going to create a list as Xplot. I'm going to talk about what it does. 0.1, 0, and 0 here. And now we can create our pie chart with plt.pie. We are going to pass sizes, Xplot, labels, and let's add a title as pie chart. And we are going to use plt.show. Pie charts allow us to visualize proportions within a whole. In this example, we have three categories, A, B, and C. The slices of the pie represent the proportions of each category. The Xplot parameter allows us to emphasize a specific slice. Let's keep with plot type known as the area plot. We are not going to use like plt.area, we are going to use fill between here, like plt.fill between X and Y we are going to pass, and we are passing an alpha value. You can try the different ones. Let's add a title as area plot. Also add X and Y labels. And we are going to use plt.show. Area plots are excellent for visualizing the magnitude of data across different categories of time intervals. In this example, we have filled area between the X values and the corresponding Y values, resulting in a shaded area plot. Next up, let's explore a plot type that's widely used in time series analysis, the Candlestick Chart. We are also going to use NumPy here. Dot plot X and Y. We are going to set color here. Let's add a title. as Candlestick Chart, and let's add X label as X axis and Y label as Y axis. And we are going to do a different thing here. plt.stem x y, we are going to say R, and we are going to set the marker here, and at the final stage we are going to use plt.show. I forgot to add an O here. Let me add that quickly, and that's nice. Okay, candlestick charts are commonly used in financial analysis to visualize the opening, closing, highest and lowest values of a stock or asset. In this example, we have plotted our dataset Y as a line chart and added stamps to represent the opening and closing prices. Now let's move on to a plot type called as the Violin Plot, which combines the features of a box plot and a kernel density plot. Let's get to another cell here, and we are going to use plt.violin plot. We are also going to show medians as true. Let's give a title here as Violin Plot and add a Y label as values, and we are going to use plt.show. Violin plots provide insights into a distribution of data similar to box plots, but also display the kernel density estimation. In this example, we have created a Violin plot to visualize the distribution of our dataset Y, including the median value. Let's explore a plot type known as the 3-dimension surface plot, which is perfect for visualizing complex relationships in 3-dimensional datasets. We are also going to import something here. We are going to say from mpl toolkits.mplot3d import access 3d. We are going to start by setting figure AX. We are going to add a subplot and set projection as 3 dimensions. That plot cover map. And now we are going to set the title here. We are going to use a different method here since we are using subplots. We are going to set the title as 3D surface plot. Let's set X label as X axis, Y label as Y axis, and at the last place Z label Z axis, and we are going to use plt.show here, and we are good to go, I think, and that seems nice. Okay, 3D surface plots offer a mesmerizing way to visualize data in 3 dimensions. In this example, we have created a surface plot using the X and Y values as the input and the squared sum of X and Y as a height. Let's keep with exploring the Hexbin plot, which is useful for visualizing the distribution of a large number of data points. For this, we are going to use plt.hexbin, and we are going to pass X and Y grid size and cover map. Let's set this to, let me think, Inferno. Okay, plt.title. We are going to add title as Hexbin Plot, And let's set X label as X-axis and Y label as Y-axis. We are also going to add plt.coverbar label is going to be equal to the count, and we are going to use plt.show. Let me check quickly. I need to change here to grid size. I made a typo there, and I think now we are good to go. Hexbin plots divide the data space into hexagonal bins and represent the number of points within each bin using colors. In this example, we have created a Hexbin plot to visualize the distribution of our dataset X and Y. Next, let's uncover the power of polar plots, which are great for representing cyclic and directional data. We are going to move to another cell here. We are going to set a theta value with a numpy method. numpy.py, and we are going to set R and now we are going to use plt.polar with passing theta and R. Let's give a title here, and we are going to use plt.show. Polar plots utilize polar coordinates to represent data. In this example, we have created a polar plot with theta as the angle and r as the radius. The resulting plot showcases the clinical nature of the data. Now let's move on to the Streamplot, a plot type commonly used to visualize fluid flow and vector fields. We are going to create a new X and Y here with using numpy methods. Mesh grid numpy.space and now we can create our stream plot. plt.streamplot x, y, u, and v. We are going to give a title as streamplot. plt.xlabel x axis and plt.ylabel y axis, and we are going to use plt.show. I made a typo there. I hope it's okay. Now it's going to work. Streamplots provide a visual representation of vector fields. In this example, we have created a streamplot using the vector components u and v. The resulting plot demonstrates the flow of vectors in the field. As the last one, let's explore the Errorbar plot, which is commonly used to represent uncertainties or error ranges in data. We are going to use the old x and y, but I don't want to write them, so I'm going to make a copy paste here. We are just going to create errors together. Absolute numpy.random.normal 0, 0.2 and 100. Okay, now we are going to create our plot with this. We are going to use plt.errorbar x, y, y errors, fmt, and we are going to set the cap size. Let's set a title here as Errorbar Plot and X label as X axis and Y label as Y axis. and we are going to use plt.show at the end. Also, let me add one more thing. We can change the color of this. E color, let's say red. And you can represent like this also. In this code, we generate random errors using numpy.random.normal with a mean of 0 and a standard deviation of 0.2. Then we pass the x and y values along with the y_error parameter to the errorbar function. The FMT parameter is set to O to use circles as markers. eCover is set to R to specify the cover of the error bars, and cap size is set to 3 to control the size of the caps on the error bars. That was all for this Matplotlib tutorial. Thank you for watching. You can subscribe for more videos like this. Have a great day.